Okay, hold on a second. Let's go back. The probability of speckled, right? How many are speckled, Ethan? Four. Good. How many total? What? Aren't there 12? You add all of them. No. All right.
That's what I did. That's what I said.
All right. Good. Can we read the question?
Yes.
Okay, good. Okay, because here's part B. One marble is picked at random. What's the probability it is clear or solid? Clear or solid. Now, there's a key phrase in there. What's the key phrase? The key phrase is or. And what do we know or to mean? Oh, it means add. Yes, good. Tell me what you got. Set it for me. Okay, so what is the let's break it down to components. What's the probability of clear? It is 1 out of 12 because it says there's one that is clear. What is the probability of solid? It is 7 out of 12. And the word or in probability is a key word that means add. So we're going to take 1/12 and 7/12, and add that together. So 1/12 plus 7/12 gives us a grand total of 8/12, which is 2/3. So obviously you are more likely to pick a solid or a clear than you are to pick a speckle. Okay? That's the basic one. Is everyone clear on that one? Any questions on the basic marble in the jar question? Feeling good? It's a ratio.
You could definitely get a spec for it.
Mm-hmm. Okay, this one. Let's talk about Vegas and the game of craps. Anybody ever played craps before? I love how your hand just shoots up. Okay, where have you played craps before?
Raul's 8th birthday party.
Yeah? Was it fun?
Yeah.
And what do you remember about craps? So a little extravaganza here. Let's figure out how we can win at craps. The first roll, okay? What are the ways that I could win? If I roll a what? Yeah. So what's the probability I will roll a 7? Yeah, it's 6 out of 36. Let's just leave it as all choices total, right? What's the probability I could roll an 11? 2 out of 36. And of course, the key word is or. We all know that or means add in probabilities. So that means I have a grand total of, I did that last period too. 6 out of 36 plus 2 out of 36 is a grand total of 8 out of 36. Let's just leave it in terms of what it is. 8 out of 36. Do we agree? Is that pretty straightforward? Okay, good. What's the probability then I'm going to lose? Well, how do I lose the game? If I roll a what? A 2, a 3, or a 12. So let's break it down to the components. What's the probability of a 2? Look at your chart. 1 out of 36, right? What's the probability of a 3? 2 out of 36, right? And what's the probability of a 12? 1 out of 36. Or means we're going to add them all up. So 136 plus 236 plus 136 is 436. Okay, so it seems like, just looking at these two numbers, we would win more than we would lose. But something has to be going on here, right? Because if that were the case, then everyone would just be going to Vegas all the time and coming home with lots of money, when we know that's not rarely the case, right? Okay, so let's go and take a look at this second part here, or this third part. What's the probability you roll again? Now, who sees it? There's something that we can do. Do we have to count up all of those?
It's just all the other things.
It's all the other things. So how can we get that quickly?
You can add these two together and then just
Subtract them.
Yeah, add them together. And so what's the total probability?
36 out of 36.
36 out of 36, which would be 1, right? Okay, so the probability that we roll again must be 1 minus the probability that we lose minus the probability that we win. So why is this 1 here? That's my question to you. Why is the 1 there? Because it represents all of them, right? 36 out of 36. Okay, so that can be 36 out of 36 minus what's the probability we win? 8 out of 36 minus 4 out of 36. So what is the grand total for 24 out of 36? So now that we have all our options and our probabilities laid on the table, okay, winning 8 out of 36, losing 4 out of 36, rolling again 24 out of 36. What is the most likely outcome of rolling the die? Rolling again. Would you all agree? And obviously there's the math to back it up, right? Now, Andrea, what my favorite question of the day? My favorite question is called the defective phone problem. Okay? This is my favorite question of the entire day. It says this. You have just received a shipment of phones from your supplier overseas. That could be lots of places. The shipment contains 100 phones to be sold in your store. So let's say you work in a Radio Shack and you just got these cute little Mickey Mouse phones, right? You've been told that 5 of the phones are defective, like they don't work. The ringer's broken or the dial's broken or something, right? And you're going to randomly pick 3 phones to sell to a customer. Okay, so do everyone understand the setup? You work at a store, a box just came in from China or wherever, they sell phones, and there's 100 of them in a box. Somebody walks in and they want to buy 3 of them, but you've been told 5 are broken or defective. You're going to randomly pick 3 of them to sell to this particular customer. Question number 1, what's the probability that all 3 phones are bad? Okay, so before we answer this, do you think it's high or low? Very low. Probably pretty low, right? What makes this question more difficult than the other questions? What do you guys think? There's more outcomes?
It's like a probability and a probability.
Okay, Inception. What else?
Well, it is. It's like
Okay, let me ask you this. What's our denominator going to be? Why do you say 100? Yeah, is that what you're looking for, though? No, okay, so the denominator is 5 now. Your denominator is 3. So we have no idea what the denominator is. It's 100. Huh? Right here. 100, choose 3. You guys get it now?
161,700.
Yeah, quite a large number, right? 100, choose 3. And then the top is, how many phones are bad? So we want all the possible ways that we could choose 3 phones from 5 bad ones. Do you guys get it now? This is a combination and probability model question linked into one. This is a tough question to answer. So I need calculator help out there. I need 5 choose 3 over 100 choose 3. That's what I need. So help me out, verify.
1, 8 times 10 to the negative 5th.
Hold on a second, dude. I'll get you there in a second.
All right.
Say again?
6.18 times 10 to the negative 5th.
That's the whole answer, or that's the numerator?
That's the whole answer.
Let's just do this. What's 5 choose 3? 10. Is it 10? I think it is 10. Yeah. So it's going to be 10 out of, what's our denominator going to be?
161,700.
161,700, comma. There you go. There. Since probability is a fraction somewhere between 0 and 1, right? Yeah. We have 10 out of 161,700 that all 3 phones are bad. You guys with me?
Yeah.
Esmeralda? Yeah? Okay.
That's pretty small.
That's a small probability, correct. I agree. Okay, answer this question then. What's the probability that 2 phones are bad? Exactly 2 phones. What's the probability that I should put exactly?
Same thing.
Okay, in terms of what?
Oh, no,
Is it really the same thing? It's not the same thing, is it? Okay, so here's what we're going to do, right? We're going to pick some bad phones, aren't we? And we're going to pick some good phones, aren't we? And we're going to divide that by the total. So there's the setup. So of all the ways that we could pick a bad phone, how many are bad? There are 5 of them, and we want to choose 2 of them. That number represents all possible ways that we could pick 2 things from 5. Correct? Now, how many are good?
95.
And how many do we want?
1.
Yeah, we want 1 of those, don't we? And the multiplication principle says that we multiply those together. And of course, we divide by the total, and the total is still the same. Right? The total is still 100, choose 3. So help me out, you guys. 5 choose 2 is 10 times 95 choose 1 is 95, right? All over 161,700. So that would be 950 over 161,700. All right. Okay. What do you think so far? We're good? Questions about this one? Because I'm going to go on to the hardest one of the day next. Yeah? Yeah, okay, here we go. Here's the question, right? What's the probability that at least 2 phones are bad? So what's the word that throws us off? At least.
The one that's
right?
highlighted.
The one that's highlighted. Yeah, there you go. Right? At least. Okay, what makes this problem more difficult? There are a bunch of different options. Define a bunch. How many are a bunch?
More than 2.
Well, are there 50? No, there can't be 50. How many do we have? Olivia. We have 2 options, don't we? Okay, these are the 2 options that we have. We could choose 2 bad and 1 good. Or, oh my gosh, there's the word again. We can choose 3 bad and 0 good. Right? Both of those situations are taking into consideration at least 2 phones are bad. Do you guys agree? Okay. And then, of course, we have our probabilities, right? From 100, choose 3, and then 100, choose 3. So you guys follow along? So what are we going to do to these individual probabilities then? We're going to add them together, right? Well, it turns out that this one is the exact same problem as the first one, isn't it? Or the second one? Yeah, it's this one, right? Because this one would be 5 choose 2 times 95 choose 1 divided by 100 choose 3. Or the other case could be 5 choose 3 times, oh, look at this, 95 choose 0. And what's 95 choose 0? 1, because there is one way to choose nothing, right? Divided by 100 choose 3. So basically we're adding these up together. So that means I'm going to have 960. 960 over, what's my denominator again?
1,617.
There you go. Okay. And here's the weighted coin problem. This one's not so bad. So here's the premise, okay? We're going to construct a probability model for tossing a weighted coin. It says weighted. It doesn't look like it, but it says weighted. Heads is 3 times as likely to show up as tails. Okay, so now all of a sudden, our equally likely events is no longer equally likely, right? Because one of them is weighted differently. So there's 2 things we need for a probability model. What's the first thing that we need? Marissa. Sorry. What's your name again? Maria. Maria. Sorry. I lost my brain there. What's the 2 things we need for a probability model? What's the first thing we need? The sample space. You got it. The sample space. All right. And we're just tossing a coin 1 time. So, in our sample space, what are our 2 outcomes? Heads or tails, yeah. Heads or tails. Number 2, what's the second thing that we need, Brody? Yeah, well, heads and tails, we got that. Take a drink of water, yeah.
You just set the probability for each one, right?
Yes, the probability for each one. So what is the probability that I will get a heads, and what is the probability I would get a tails? Okay, bring your own water bottle, okay? Okay. Probability of getting a tails, what would it be? No, it's not 1/2 anymore, is it? I hear 1/4, 1/3, 1/6, 1/6. Well, let's do this. Let's call it X. I don't know. How about that? That's always the safe bet, right? I don't know. Let's call it X. So then what would probability of heads be? 3X. Very good. Probability of heads would be 3X. Now that gets you out of all these situations, okay? Now, what does the probability always have to add up to? Oh, so you mean 3X plus X is 1? So 4X is 1? Ah, so X is 1/4. Okay, how do we apply that? What's the probability of getting a heads then?
3/4.
It would be 3/4. What's the probability of getting a tails? There you go. Heads is 3 times as likely.
Wow.
Different, right? Oh yeah, thank you. They're clapping.